Hey everybody, in this video I'm going to do a deep dive on the Ford Pro Power Onboard generator system, which is available on late model F-150s, from the 2 kilowatt system to the 2400 watt system, all the way up to the 7.2 kilowatt system available on the powerboost. I'll show you how it works, and I'll show you how to make it not work. I'll show you how to use it for typical applications like running tools out of your truck, or maybe even backing up your home power in the event of an outage. I'll put section markers in this video, so feel free to skip around and find the information that you want. All right, let's roll.
Section 1, what is Pro Power Onboard? Well, Pro Power Onboard is Ford's version of a truck-based mobile generator. You can see in this case, this gentleman is actually connecting a welder, an arc welder, to his truck through the 240 volt outlet, and he's actually doing some welding here. So this is typical applications where the truck can provide mobile power pretty much anywhere that you can run your truck. There are 3 versions of Pro Power Onboard available in late model F-150s, depending on what model truck you order and what options you add to your build. Now, if you just get a gas truck, so this is a 3.3 liter or 2.7 liter or 3.5 liter non-hybrid, you'll get a 2 kilowatt generator as an option. This is the only option available for gas-powered trucks, and it features 2 120 volt grounded outlets that together can supply 2,000 watts of power, or just over 16 amps at 120 volts. Now, most competitive offerings don't do more than about 400 watts or 3.3 amps at 120 volts. So this arrangement uses a floating neutral connection from the generator. And Ford provides a nice graphic here that shows typical applications that you can use 2 kilowatts for. So you can run power tools with this. You can charge batteries with this. You can run electric heaters that are less than 2,000 watts. You can run televisions, portable speakers, fridges. You can do quite a bit with 2,000 watts at 120 volts, not to minimize what the 2 kilowatt system can do. However, there's also a couple of other models. These are all centered around the PowerBoost Hybrid, and the default version is the 2.4 kilowatt. So if you don't order the optional 7.2 kilowatt, you will get a 2.4 kilowatt as part of your truck. This ups the wattage to 2,400 watts from dual 120 volt outlets, or 20 amps of draw at 120 volts. Ford claims that on a full tank of gas, this version can keep the electricity flowing for up to 85 hours. That's quite a bit. This arrangement uses a bonded neutral connection. You'll see how that is important later on. And again, with the Ford graphic here, you can see what you can do with 2.4 kilowatts. You can run compound miter saws, which are generally larger air compressors, battery chargers, jackhammers, concrete mixers, popcorn machine, projectors. 2,400 watts is quite a bit. It's more than most house outlets at 15 amps. And finally, we get up to the optional 7.2 kilowatt Pro Power Onboard system. This generator is optional on hybrid versions of the F-150 and offers 4 120 volt outlets plus a single 240 volt outlet to power a variety of commercial equipment at full load for up to 32 hours on a full tank of gas. From the 120 volt outlets, you can get 20 amps per circuit, 2 different phases. And with the 240 volt outlet, you can get the full 30 amps per phase for the full 7.2 kilowatts. This arrangement also uses a bonded neutral connection, which, as we'll see later, is important when we go to power our entire house. Now, at 7.2 kilowatts, now we're having a lot of fun. This is an electricity party here, so you can run a whole crew framing a house with compound miter saw, circular saw, gang battery chargers, hammer drills, all of this running at the same time. Or you can be a mobile metal shop. You can run a full crew on this, or there's several different things. I mean, you know, obviously we could go on, And later on in this video, you will see some examples of using tools simultaneously. So that's Pro Power Onboard. You have a mobile generator, which is part of your truck and offers class-leading power generation capability. Now, let's see how this system actually works. Section 2, how does the Pro Power Onboard work? I personally think that it's important that an owner has at least a passing knowledge of how the system works, as it will help you get the most out of the Pro Power Onboard system down the road. And it will also help you from getting into situations where you're asking the system to do something that it was not designed to do. My own opinion is that Ford did a great job of building this system and a really poor job of communicating how to use it properly and what it can and cannot do. This is an actual system diagram from Ford about the Pro Power Onboard and the hybrid system. So everything starts with the battery. So the battery is underneath the bed, and this is the 1.5 kilowatt hour lithium ion battery. So as you know, the PowerBoost hybrid system has a 3.5 liter internal combustion engine driving a combination motor and then transmission. So the motor is in line, but guess what? This motor can also be a generator. So basically how this works is the battery drives the inverter with DC, and then the inverter takes the DC or direct current and turns it into alternating current at 120 volts per phase. And then it distributes that to the distribution box here, where it's either going to pick up one phase for 120 volts or both phases for 240 volts. Now, the battery by itself would be able to power various loads for various periods of time, depending on how much load that you're asking for it to deliver. Light loads, it may be able to do it for quite some time. However, most of us are using heavier loads, like if you're running tools or lights or heaters or anything like that. It's not going to be able to handle that for very long before the battery is going to discharge, which can be very harmful to that battery. Battery typically runs in between 38 to 70% charge. And so the system tries very, very hard to keep it within that window. And so this is where the combination of the internal combustion engine and the motor generator kick into gear. So you will see during the examples sometimes where we turn on larger loads that depletes the battery, so the engine will kick on and tell the motor to be in generator mode, and will recharge this battery. So it's a really, really slick system. Now, this is the hybrid version of this in the gasoline powered engines. So again, the 3.3, 2.7, and 3.5 liter EcoBoost and the 5 liter gas engine, they don't use this. Use something slightly different, a little bit more simple. In fact, let's get into that right now. This is the 2 kilowatt non-hybrid system. So this is for the gas engines that are out there. Now, first of all, the engine must be on. The engine must be on. There's no passive battery just sitting in there providing power. So the engine's got to be spinning, generating power through the alternator. So it's the battery in the alternator is going to supply DC into the inverter. That inverter is going to take the direct current, turn it into alternating current at 120 volts. And there's 2 kilowatts of capacity there. So roughly 16, 17 amps or so in a single dual outlet there. So it's a very simple system. However, most other manufacturers don't do it this well. They only provide somewhere around 400 watts. So there's your 2 kilowatt non-hybrid system. Now we're going to move up to the default system, or the base system for the PowerBoost, the 2.4 kilowatts through the hybrid system. And again, everything centers around the battery, because the battery in the DC-AC inverter could power your outlets in the bed for quite some time, depending on what you are doing with them, depending on how much you're drawing. Certainly not for very long at 2.4 kilowatts. So this is why we have the internal combustion engine. In this case, it's going to be the 3.5 liter EcoBoost which is driving the electric motor generator via gas. So the energy is being supplied into this system through the internal combustion engine from the gas tank, right? So this is the way that the system flows. And you're getting one phase of power through this. So you're getting one phase of 120 volts into this outlet back here. So I believe it's a dual outlet. So again, as we've noted, 2.4 kilowatts, that's nothing to sneeze at. That is quite a bit of capacity, but it's nothing compared to the 7.2 kilowatt system. This is really the game changer. So there's plenty of capacity here. So everything's the same here as in the 2.4 kilowatts. What's different is that we have, first of all, on one phase, so we'll just call this phase A, that's 120 volts, and it's feeding half of the 30 amp 240 volt connector. And then there's the B phase over here, and we'll see this in action in a couple of minutes. And that's also feeding 120 volts to the other side of the 240 volt connector. So that 120 volts is also feeding this outlet on A phase. You can see A and B here on the connectors. And it's also feeding 120 volts down here. So these are separate outlets on different circuits. As an electrical nerd, I really get off on this. I think this is amazing. This is really, really well designed. And my hat's off to Ford for how well they produce this. Something very important now, the outlets on the Pro Power Onboard generator system are GFCI protected. That stands for ground fault current interrupted. The 2.4 and 7.2 kilowatt versions have a bonded neutral. They cannot have any current flowing through the ground circuit, or the generator will shut down in fault mode. We'll see later that this can be a real issue when trying to power an entire house via the service panel. So what is this GFCI? Well, if we have the generator on one side and then there's a load, and let's say we're connecting them through a ground in the green line here, if the current flowing out of the generator does not exactly equal the current flowing back via the return or neutral, then the current is assumed to be in ground fault. So somewhere there's a passive leak of current, and it's more than likely coming through on the ground, which means that you may have some leakage current on that load device, and it could be potentially hazardous. This is called a ground fault, and will show up in a message on the truck's Sync4 interface because it's going to stop the generator. It's going to shut it down into fault, and you're going to get no voltage on the outlets. So it'll happen faster than you can blink. All right, so that is a very, very high level explanation of what the Pro Power Onboard system is. So now let's dig a little deeper by showing what a generator system like this can and what it cannot do. Section 3, design limitations of the Pro Power Onboard system. Now, this is not just the limitations of the Ford system, it's also limitations and characteristics of delivering big chunks of power into large loads electrically. This section has all the nerd stuff, which will help you know more information about what the system will and won't do. And I would predict that these topics will also be the source of 100% of the arguments in the comments section. I've been part of truck forums for a long time, and these topics tend to produce the saltiest arguments out there. I don't know why. It's either that or oil threads. The first thing that we need to establish for the operation of your Pro Power Onboard generator system is that all loads are not the same. First off, we have resistive loads. A resistive load is one where we're converting current into heat, or converting current into light via heating something up, just like Edison did. This is a very simple type of load for the generator to power, and you can generally take the power rating of the load at face value to determine how to connect it to your generator. This is all very linear. So for example, a 1200 watt space heater will draw about 10 amps at 120 volts. If we Take that 1200 divided by 120, we're going to get about 10 amps. Everything fits nice and neat with resistive loads. But then we get into reactive loads. This is where things get messier. A reactive load is a complex alternating current load that has inductive and or capacitive components in the load. The current is not a constant like in resistive loads, as the circuit can briefly look like a dead short when first engaged. Look at this example of, say, like a motor here, where we feed this, and initially this winding is going to look like a dead short with some small amount of resistance in there, but it looks like a dead short all the way across the load until we start to see the motor spinning up and generates counter EMF and the current goes down. We'll discuss that in a minute. Common applications would be air conditioners, rotating power tools, refrigerators. Something that moves is generally going to be a reactive load. When we compare resistive versus reactive loads, with a resistive load like a work lamp or space heater, we can figure out that the peak power draw will typically be constant. Power budgeting across the phases is a simple math problem to determine which phase has the spare capacity that will draw from this load. Now, with a reactive load like a circular saw or compressor, the startup current will be much higher than the operating current. We'll see this in just a minute in one of our examples. It's really cool. Whatever phase that we plug this load into will have to have plenty of headroom to handle that initial startup current. Otherwise, we'll pop the breaker for that phase or put the generator into fault mode. Tools are usually rated at peak startup load. Now, if we want to deal with this in an elegant manner, something that can help this inrush current is to use a soft start controller. So people use them on tools. People also use them in RVs for their air conditioner. When it kicks on, the compressor kicks on. Using a soft start controller for that is generally accepted practice. So if you're having trouble with the generator faulting on startup with your tools, this type of device might help soften the current spike on startup. You can see this in this example here, this diagram. Without the soft start, we're going to have this inrush current spike, which is going to be instantaneously almost infinity for a very brief period of time until it starts acting like a motor and less like just a big hunk of wire. And eventually the current comes down, no load current. And then if we start sawing some wood, and actually we are going to see this exact example here in just a minute. Now, if we put a soft start controller on here, this will help sort of slow down and soften that initial spike. There will be an initial spike as the motor gets up to speed, but then no load current is about the same and everything operates the same after that. So it helps to reduce that surge current, that spike initially with a soft start controller. Another limitation or challenge is powering a recreational vehicle with 120 volts. Normally 120 volts, you'd want to be using one of these outlets down here, the 120 volt outlets, but those are only good for 20 amps. Most circuits that you feed an RV with requires a 30 amp circuit. So in this case, what we're going to do is we're going to use the 30 amp per phase capability of the 240 volt outlet, and we're only going to use one leg of that. We're just going to use one phase. I'm not going to use both phases of that. So this is going to give us 3,600 watts of capability. And we're going to use what's called a dog bone cable. This is a dog bone cable. This gives you a single phase, 120 volt, 30 amp service to your RV or any other high current single phase application that you need. But this is very, very common across the RV space using generators with trucks like this. Another limitation, again, this is not necessarily specific to Ford. This is, everything shares this. The ampacity of your extension cords are based on wire gauge and composition. Now we're going to focus on copper over here. And this is a typical extension cord or NM cable, things like that. This is standard wire gauge. 14 wire gauge is going to give you 15 amps of capacity. 12 gauge will give you 20 amps of capacity. and 10 gauge will give you 30 amps. So you can see that that RV cable had better be a 10 gauge wire or bigger. So if you go cheap on your extension cords, there's lots of cheap extension cords that are out there that are 16 gauge, 18 gauge, and don't even think of using those white ones that you use for the Christmas lights. You might have significant voltage drop to your load, or even a fire hazard if you run a cord above its rated capacity. Now, power management. Ford loves to publish these pictures of what is typical work site with every outlet filled with an extension cord. Again, that's fine, but keep in mind that your total draw must be less than 7,200 watts, and more specifically, each phase. So each side of this must not exceed 3,600 watts, and that includes, the only way you're going to get up to 3,600 watts is to use the 240 volt connector as well too. So that's counting both the 240 volt outlet as well as the 120 volt outlets. Monitor your loads through the Sync 4, your big dashboard information center, or the Ford Pass mobile interface will also do this as well to ensure that you're balancing your loads across both phases. We'll save the best for last. We'll dedicate the last section in this video on the requirements needed to power a home during an outage. That is the gold standard of using the F-150 for power backup. So now let's have a little bit of fun. Let's see some typical applications for the Pro Power Onboard using the 7.2 kilowatt generator system. Here we go. Here is section 4. This is the fun stuff. Simple Pro Power Onboard applications. The examples that I'll show here are done using my 7.2 kilowatt Pro Power Onboard generator from my 2022 XLT Power Boost. And the first application is a simple work lamp. This is a resistive load. This is probably the simplest application that we can ask for from the Pro Power Onboard generator. Now, to get Pro Power Onboard going, probably the easiest way to start this, first of all, start the truck using the ignition switch and then select Pro Power Onboard, that hard button on the upper left-hand corner. Next, you want to go into Features from the main screen. So go into Features and then select the Pro Power Onboard and ensure that you're in generator mode. If you're in generator mode, you'll be able to provide up to 3,600 watts per phase. So far, I'm drawing less than 200 watts per phase. There's really no draw on the generator at this point. All right, let's go outside. Let's plug in our work lamp. We can either choose phase B or phase A. I'm going to choose phase A and plug in the work lamp. And as soon as I plug it in, this is supposed to be a 500 watt work lamp. It's showing about 490 watts, which is just about on target. It's interesting to note that the truck is not even started. This is running straight off of battery power into the inverter at this point. So I'm going to unplug this. We can plug it into phase B, and you can see that it's also providing 490 watts through phase B. So it doesn't really matter which one you plug it into if that is the only load on the circuit. All right, so that's a resistive load through a work lamp. Very simple. Let's increase the complexity now of our loads. We're going to add a second load. Both of these are resistive loads. Okay, this time we're going to use that same work light, 500 watt work light, and we're also going to add this movable air heater, and it's supposed to be good for 1,500 watts. So this will be a good test if that is the true draw of this thing. So first of all, we're going to run these on separate phases, and then we're going to try to run them on the same phase and see if that's possible. All right, I'm going to plug the work light into the first phase, phase A on the left, and you can see there's 490 watts again. And now I'm going to turn on the space heater and get it up to the high setting, which should be close to 1,500 watts. Eventually this warms up and we get it over 1,000 watts or so. And now what I want you to listen for is, at this point, the engine's not running. This is all running off the battery, and here comes the engine. Boom. So now what we have is the generator is charging up the battery, running the inverter to drive these two resistive loads. So that's on two different phases. Now what we're going to do is we're going to plug the work light into the right-hand phase, or phase B, and we're going to run them both on the same outlet. And this is running about 1750 watts, and 1750 watts is about 14.6 amps at 120 volts. So that's well within the capability of this single phase. Adding heat and light are simple loads for any generator. Now we're going to make things a little bit tougher with construction tools. These are all reactive loads, and these are going to be very complex and can be difficult for some generators to handle. Let's see how we do. Time for a little power tool application. So what we're going to do in this test is we're going to try a few different things at once. First of all, we're going to run this air compressor that I have here, and the air compressor says that it's going to pull somewhere around 12 amps right in there. Okay, and then we're going to run this circular saw, and the circular saw says that this is good for about 13 amps. It's going to pull about 13 amps, and I don't know if that's startup or during load. We'll find out. And then I've also got this Milwaukee charger for a battery charger, and we're going to run that with a couple of batteries on there, and it says 2.1 amps. So we're not expecting a whole lot of draw from that, but we'll see what it does. So we're going to run these three individually. First of all, the compressor, the circular saw, and then the charger, and then we're going to try to use them all at once and see what we're going to need to do to balance out the power between the two different phases that are available on the Power Boost generator. All right, we're going to look at the tools individually now and their draw. We're going to start out with the compressor. Here's the compressor. It was rated for 1440 watts, and I think this is going to peak out at about 1180. The more air that gets in that tank, the harder it is for that motor to pump, and so it's going to draw just a little bit more as it continues. So there's that 1180 figure. We'll turn that off. Now we will go for the circular saw. So we're going to plug in the circular saw. We're going to plug it into the opposite phase, not the same phase, the opposite phase, phase B in this case. Now, and watch what happens when I hit the trigger on this. Watch the spike in the draw. So a quick spike up at about 1700, and then as I start sawing the wood, it's much, much less than that. It's about 900, 930 or so, 970. Now, if the saw starts to bind, it's going to draw a lot more current, like this, if you have bad clamping technique like I'm showing here. Okay, so now what we're going to do is we're going to put the batteries in so that the charger's got some kind of draw, and plug this in. Remember, this was rated for about 252 watts. And what we're seeing right now is on the watt meter, it's not even showing up. It's not even 200 watts. So that's going to register as below 200 watts. So now what we're going to do is turn everything on. We've got the compressor in phase A. We've got the circular saw in phase B. Look at that spike to 1970 and then back down to about 19 or 900 again. Notice the compressor phase is peaking out at about 1300. Now, if we subtract the 1180 from the 1300, we're left with about 120 watts, which is about what the charger is drawing. Before we leave this power tool example, there's a couple of points to discuss that I think are really important to capture some points here. So first of all, the question on the table is, could we have just used one phase? Could we have just used one side, phase A or B, to power all those tools? And a lot of this is for all of you 2 kilowatt and 2.4 kilowatt Pro Power Onboard users, because you only have one set of plugs. You only have one phase to work with. So you're going to have to be used to husbanding your power. Now, the peak on the compressor and charger was 1300 watts, right? So that was on phase A. Phase B was the peak on the saw, 1970 watts. So if we do the math, if we add those together, 1970 and 1300, that gives us 3270 watts at peak, which is technically less than 3600 watts and within spec for my 7.2 kilowatt system. However, if we're using 120 volts, if we're using those standard plugs at the bottom of the Pro Power Onboard, each phase is only rated at 20 amps at 120 volts. It says it right on the outlet cover. So if we look at the amperage here, 3270 watts, if we divide that by 120 volts, we're going to get 27.25 amps. That's way over. So probably would have popped a breaker on that phase or threw the generator into fault. I'm all for experimenting, but with somebody else's truck maybe. So practice common sense phase management with your loads. Understand what your loads are and make sure you balance the two phases between phase A and phase B. And of course, I'm talking about the 7.2 kilowatt system here and not one of the 2 kilowatt or 2.4 kilowatt PPO systems. Now, we talked about this in an earlier section of this video, talking about reactive loads. They are a dead short for a short period of time. The circular saw had a peak wattage of roughly double the running wattage. So when we started that motor up, it's basically a dead short for a very brief instant of time before it gets running, and then the motor balances out in terms of the EMF inside. All reactive loads are like that. So unless you're using something with a soft start switch on there, you're gonna have this type of issue. If you do not manage your peak wattage loads, you will end up popping breakers or putting your Pro Power Onboard system under fault. You have to clear that and restart it again, and either find a different tool or use some type of soft start. The next application is a pretty common one in the case of a power outage, which would be to light up our home refrigerator. So what I did was I unplugged my refrigerator and ran this off of the Pro Power Onboard. I've got the truck running, the generator on, and I've got a nice 12 gauge extension cord plugged into the truck, up to the kitchen, into the refrigerator. And no matter what I could do, I could not get the compressor to kick on. This should be running somewhere on the order of about 468 watts, but I could not get it to turn on. So there we go, the refrigerator running off the generator. Let's finish up with section 5, perhaps the most important application for Pro Power Onboard, powering your home with a Pro Power Onboard system. Now, when I ordered my powerboost, I originally just kept the 2.4 kilowatt default generator system in there because I just didn't think I needed the 7.2 kilowatts. And then I lost power for a weekend, and I came to my senses. On the following Monday morning, I called up the sales manager and I had them revise the order back up to the 7.2 kilowatt system. And I'm glad I did. You don't realize how much you depend on electricity in your house until you've lost it. And that made that very apparent to me. So we're going to cover the very first and simplest way that you can back up your house, and that's through extension cords. If there is a temporary power outage at your house, the simplest and quickest solution is often to just run extension cords to important systems at different locations in your home. Now, we never know if it's going to be a quick power outage or not ahead of time, but usually you know, and oftentimes the utility companies will text you and give you an ETA for service. So if it's going to be that day, then just run some extension cords and get things up quickly. I would emphasize that you have to prioritize your critical loads. Get these up first, such as your refrigerator. You don't want food going bad. Your freezer, you don't want things melting in your freezer. The sump pump, if you have an electric sump pump, and especially if the weather's bad outside, you've got to get this thing up and rolling. Or if you have water that comes in non-commercially through a well and requires a pump, you got to have water. And if it's during the wintertime, perhaps a small space heater, if you can get everybody to congregate and make sure that that heater does not exceed the current capacity of your wiring. Getting a microwave up and rolling could be very, very important to keep everybody fed. And it's nice to have some lights too. It gets really oppressive when it's dark all the time. So get those critical systems up first to sustain life and save your food. Let's talk about extension cords for a minute. Run one extension cord to each service area. So you might have one extension cord running into the kitchen, maybe one in the basement if you have, again, like a sump pump or something like that. Run one into each service area and terminate it either into the load or with a quality power strip. Please do not use those little two-prong extension cords that you use for Christmas lights. And don't daisy chain power cords either. Think ahead before your next outage. Do some planning so you have extension cords that are long enough and husky enough to do the job. And make sure you check that load in the cord to ensure that it's not overloading the ampacity of the cable. We went into the wire gauges and capacities just a few slides ago. And that you're balancing the loads correctly on your Pro Power Onboard. Make sure that each phase has a little bit of headroom to it in case there is a current spike. With the extension cord method, you're not going to be able to back up any centralized climate systems like heating and cooling if you have central air or a furnace. Point solutions will have to do if you have the power budget, such as a space heater or maybe even a window air conditioner if you have the budget for that. Don't forget, all of the outlets of the Pro Power Onboard are GFCI. So any questionable loads where there is leakage to ground will put the system into fault and you'll have to restart the system again. You might want to test your system at least once before you actually do need it. Trying to figure everything out for the first time in the dark and during a storm is a recipe for stress. For most homes and outages, this extension cord method is fine and is all that you'll need to survive until commercial service is restored. And now we get to what's got to be the killer app for the Pro Power Onboard, which is full home power backup. This is what a lot of people buy this capability for without really understanding how it works or how to integrate it. Let's get into it now. Before we go any further, please understand I am not providing electrical advice. Before you change anything to your home's electrical system, please consult with and hire a qualified electrician. I am not an electrician. My only goal is to show you what I've learned about the Pro Power Onboard system and how some people have gotten it to work with their homes. So here's what most people buying an F-150 with Pro Power Onboard think that they can do with their home. Here's the vision. Power coming from the utility is interrupted at the transfer switch. Normally this goes into the main panel. So it's interrupted, and so what we're going to do is we're going to take that transfer switch. Normally it's going to be thrown over to this pole, and we're going to swing it over to this pole here. So we're going to connect the Ford Pro Power Onboard through an umbilical cable into a transfer switch, fire up the generator mode, and then boom, all of a sudden, all these circuits are going to be lit up and working with 240 volts. And we're good to go. But here's the reality, and I've seen this so many times from people saying, hey, I did all this work wiring up and buying all these cables and everything like that, and it immediately goes into ground fault. What's going on? And then they've got to go through this whole education process to begin with. So this is one of the reasons why I created this video, is to help people avoid that time and expense to begin with without getting an understanding of how this actually does work, and what it will do and what it won't do. So the Pro Power Onboard is a bonded neutral generator. What does that mean, and why do we care? Well, the majority of all main panels have grounds and neutrals connected on the same bus. We can see this here. This is a typical bonding bus, and you can see the white wires, which are typically neutral, and the bare wires, which are ground, and they're all connected on the same bus. They're all tied together. This is extremely common. So if you feed this type of panel with a bonded neutral generator, this means that the return current will split between ground and neutral and will immediately put the Pro Power Onboard generator into GFCI fault. Let me draw a little illustration here which might help. So if we start out with our generator over here. So here's our generator. This is the Pro Power Onboard. And then let's say this is the panel, the main panel. And let's tie them together with in this case, a hot, and then let's use white for the neutral. And then here's green for the ground. And let's tie these together at both ends. This is a bonded neutral. And then here's the main panel with everything bonded together. Now, think about this for a second. Current goes out on the hot. And remember how we determined ground fault current interrupter, right? GFCI. Because what we're doing is we're seeing if 1 amp going out of this is going to be 1 amp coming back on the white neutral return. Well, what happens is when we tie these together, when we tie the white neutral together on both ends, then the current's going to be split on the way back. Current's going to be split on the way back. And so there's no way that this white wire is going to have 1.0 on it. It's going to have something less than that because some of it's going to be coming back on the ground. That's an immediate ground fault. At least that's the way I understand it. If I'm wrong, please let me know in the comments below. Some people work around this by severing the ground lead of the umbilical feed cable back to the Pro Power Onboard generator. Obviously, that would force all of the current back through the white wire. Please do not do this. There are a couple of ways to accomplish whole house or partial backup via the Pro Power Onboard. Now, one way that I saw was a whole house backup via a manual switch. This is actually pretty cool because it does actually back up the entire house. The entire house can be lit through this method. And so you can see in this case, the generator is being connected to this plug over here. Here is a manual switch, which is going to switch in between commercial power versus backup power. And then here's your meter and basically the service entrance into the house. This is an existing Pro Power Onboard connection to a customer's entire house. The entire house is backed up via this method. Now, the way they got this to work is because the home's main panel now becomes a sub panel by separating ground and neutral bus bars. This will prevent the generator from going into GFCI fault. The owner still needs to be aware of loads in the house. This is a 200 amp service coming into the house, and you've only got 30 amps coming in through Pro Power Onboard. So you've got to be very cautious and careful about what you're going to turn on. Maybe you can't use all the compressors in your air conditioning. Maybe you can't use the electric heater for your heat pump. There's going to be some things that just won't work on a 30 amp service coming in, which will work on commercial power. So this job can be upwards of $5,000. This is not a trivial job to redo this. I listed the YouTube link of the electrician who built this in the description area below. I encourage you to check out that video and contact that electrician if you're curious about this type of solution for your house. Again, this is a whole house backup via a manual transfer switch. The other way that I've seen people do this is partial home backup via something like a home link switch, which is built by Generac. So using a transfer switch like this, like the Generac 6852, you can wire up to 8 circuits, which will be backed up by your generator. So if you think about it, this is a more elegant way and a cleaner way of doing the whole extension cord type of point solutions. These 8 circuits are going to be identified for priority loads, right? And they're going to be wired correctly with separate ground and neutral so as not to put the GFCI system into fault. So the home link forms a separate sub panel, if you will, for critical circuits that'll be backed up. And you're going to pick things like a fridge or the furnace or some lights, maybe your office, things like that. So this is where you have to design those and run those circuits separately to this panel. This panel runs about $400 itself and will require an inlet box, generator cable, plus wiring to tie into existing commercial service to feed these circuits when not on a generator. It's a relatively simple job, although you do have to rewire those 8 circuits into this panel and out of the main panel. I've listed a YouTube video showing an F-150 installation in the description area below. So yes, you can do a partial or a full backup of your home using the Pro Power Onboard generator. However, some or maybe considerable effort and expense is going to be required depending on how you want to achieve this. Balance the effort and cost to do this versus the likelihood of being out of service for several days. If you think it's just going to be an intraday outage, some extension cords will work just fine. Full integration into the main panel would be a perfect solution for a home that's off-grid, such as a remote cabin. Wow, I had no idea when I started putting this video together that it was going to turn into a 45-minute monster. So that's the thing about these videos, though, is my subscribers ask me to get into this topic because it's fairly complex. And next thing you know, 45 minutes later, here we are. Thank you for making it all the way through this video. It's people like you that I create these videos for. So I would be honored to hear any suggestions that you have for any other content that I have. And I would also be honored if you're not a subscriber yet, if you would go ahead and subscribe to this channel, because this is what I want to do. I want to create content for people that need solutions for either this truck or other types of topics like this. So thanks very much for getting through this video, and we will see you in the next one. Look forward to seeing you there.